Okay, let's have a look at question 2. Okay, so this is interesting, a little bit interesting because at first glance, it's not something year 3 students should be able to do. Okay, but I want to investigate if it is something that year 3 students should be able to do. Okay, so it says a point D, okay, lies on side AC of triangle ABC.
On the aimo, I didn't fully understand it, but I understand it a bit. But
yeah, so I think
I
can make it easier for you by drawing the picture for you, okay? But I think you should try to draw the picture yourself first, and then I'll tell you how to draw the picture, okay? So D lies on side AC of and you get 1 point in this test if you draw the picture, okay? And it's only worth 2 points. So triangle ADB is isosceles. So ADB, triangle ADB is isosceles. With DA equals DB.
What does isosceles mean?
Good question. So DA equals DB. So isosceles just means two of the sides are equal in length.
Oh yeah.
And there's one right angle.
No, there does not have to be a right angle. Triangle DBC is also isosceles. Triangle DBC is also isosceles. What the? Okay, where is that? Okay, so triangle DBC is also isosceles, okay? And with BC equals BD. So it's telling you which sides are equal as well. All angles in triangles ADB and DBC are an integer number of degrees. So all the angles in these two triangles are an integer number of degrees. What is the difference between that? So I'm expecting someone to ask, what does that mean? Okay, if you like, you either know what it means or you're trying to figure out what it means. There's no way that you're gonna be like, oh, I just don't know what that means and I'm gonna accept it and not ever resolve this issue. Okay, that's absolutely unacceptable. Do you understand? So it's either you know it, you're trying to figure it out, or you're asking me. Okay.
What is integer number?
Yeah, there we go. Okay. So it means that you know what angles are, right? Do you know what I mean with 60 degrees?
Yeah.
Yeah, so the angle can be 60 degrees, 59 degrees, 58 degrees, but it can't be like 58.3 degrees, okay?
So like it has to be a
whole number, yeah. Okay? So the angle, it has to be a full number, so it can't be 60.5 degrees, okay? It can't be like a fraction of a degree, okay? Okay, so the question asks, what is the difference between the largest and smallest values that angle ADB could have? So let's look at angle ADB. What is the difference between the largest and smallest angle? Okay. And I mean, I want you to draw a diagram, okay? So this is obviously what's called a geometry question, right? We talked about geometry before, yes? At the very beginning, remember? So we have geometry. Okay. So in the same way, when we're doing number theory, so just then we did number theory, we could try numbers by calculating 3 times this, 3 times that, 3 times that, right?
Okay.
We could figure out what all um the products are to figure out how to do the question. Michelle, what are you doing? Sit on your table and do this, okay? So you can figure out how to get more and more info about the question by doing lots of number crunching, okay? For geometry, a similar thing can be done with the diagram, okay? So you can draw lots and lots of different diagrams to experiment with the problem. You understand? Okay, so I'll give you 2 minutes to draw a diagram, and then I'll draw a diagram as well. Okay. So get a piece of paper. So this you should like this because you like drawing stuff.
I do like drawing.
Yeah. A lot of my students, like after a while, they just instinctively start drawing the diagram as I'm saying this. So they don't have to waste time. You draw a diagram. Get a piece of paper. Oh.
Diagram. Diagram.
Yeah, D is on side AC. See, D lies on AC. So D is on here. Okay. Your D is in the middle here. Draw another diagram.
I do it. I do it.
Okay, that covers that bit. But how do you get ADB as isosceles? ADB isosceles, yeah. DA.
Oh yeah. Yeah, that's much better.
No. If triangle is like this. You didn't understand. Look, that's what that is. Alright, so let's have a look at the diagram. So it's okay to draw a diagram and it's bad. You just draw another one, okay? So you have a triangle ABC, yeah?
Yeah.
Okay, D lies on AC, so D is somewhere here, right?
And you draw a line, to B.
ADB is isosceles, so that means with DA equals DB. So this line here is meant to be the same length as that line, right?
Yeah.
Okay. DBC is also isosceles with BC equals BD. So it's actually this is equal as well, you know?
Yeah, it is equal.
Diagram.
It's better than before, okay? But are you watching?
Oh yeah, that is equal. Yeah. Because it's isosceles.
Okay, and then the question is asking about angle ADB. Okay, what values can this angle be? Okay.
Like what do you mean by values?
Press key. Well, okay, so now I know what roughly the diagram should look like. I can draw a diagram again. Okay, so I draw a triangle. So let me try to draw a triangle. So I need this length to be the same length. So I put D there. And I need this length to be the same length. So that's not easy to do, is it? I almost need... I need D to be like in two places at once. Right.
My diagram.
Right, so it says DBC is isosceles. That is the weird one.
Oh.
Come in. Okay. So DA equals DB and DB equals BC. Oh.
Are you honest? No, he's
Oh.
William. There's different things from red.
Yeah, so it's going to be a little bit hard to draw this diagram completely because it feels weird that this BC is equal to BD, you know? Okay. And the question asks, what angles could this angle be, okay? How big can it be and what's the difference between the biggest and smallest? So what the range of the angles is, yeah? Yeah, so okay, another way to draw this diagram, I guess, is you could draw the isosceles triangle first. Okay, and then try to draw another isosceles triangle. Okay, you'll find that this is pretty much impossible. It doesn't say D can't be C, which is strange.
It is strange.
Okay, so do you guys know, so isosceles means these two sides are the same, yeah? but it also means these angles are the same, yeah? So it means like this angle here is equal to this angle here, okay? And it also means that this angle here equals this angle here, right? Stop making that sound. Okay, so the question is, how big can this angle be? Okay, or how small can this angle be? So remember, the kind of things that we want to use here, if I recall, like, if you have a straight line, okay, then these angles add up to 180 degrees, okay?
Yeah.
Okay. If you have a triangle, the angles also add up to 180 degrees, okay? And these are basically the only things that we're probably going to use, alright? So for example, can you tell me what this angle is here? Hmm?
Acute.
A what?
Acute.
No, there's no way you can find out exactly what the angle is unless you have some maybe more insight. It's just you just know this has to add up to 180 minus these two circles, right? Maybe I'll use another symbol. How about I use a red dot for this, okay? So it's 180 minus 2 red dots. Yeah? And here, can you see what this angle here is? So by the same reasoning, it's 180 minus 2 black dots, you know? But can you see another way of getting this angle? So it's actually also 180 minus 1 red dot, right? Yes? Can you see that? Oh. Okay, I feel like you guys have like maybe not enough brain left to even do anything. Maybe I will talk you through it a bit more, okay? So, can you see? So the reason why it's 180 minus red dot is because it's a straight line, right? It has to add up to 180. Michelle, you can leave, okay? Okay. So, do you know what an obtuse angle is? What an acute angle is?
Acute angle is like smaller than 90 degrees.
Yeah. So if the whole angle is 180, right? And there's two angles, yeah? They can both equal 90, yeah? Or one of them has to be acute and the other one has to be obtuse, right?
Yeah.
That makes sense? Okay. So can you see why the red dot can't be equal to 90 or more? The red dot has to be acute. Why does the red dot have to be an acute angle? Okay, so remember the angles in a triangle have to add up to 180, right? Yes? So if you have three angles that add up to 180, yeah? You can't have two of them adding up to 180, yeah? Because then you get an angle of 0 or negative angles. Okay? So the fact that there's two red dots in a triangle means that they have to add up, they have to all both be acute, okay? For example, there's lots of other ways to see it as well. So if it's an acute angle, it means it has to be less than or equal to 90. It has to be less than 90, okay? Yes? Yeah. So if that's less than 90, then the other thing has to be more than 90, right? So this angle here is more than 90, yeah? Yeah. So you already know your answer has to be less than 90, right? What else? Okay, can someone tell me what the angles in ABC add up to? Like the big triangle ABC. I know you can.
ABC.
You got the first question right. I haven't marked the others yet. We're marking them right now, I guess.
I just realized I got it wrong.
Oh.
I forgot to consider ABC.
Justin and Jason, are you still alive?
Yeah.
What are the angles add up to? What do the angles add up to?
$540.
What? No. Triangles, they always add up to 180, right? But it's just... I'm talking about... So, okay. I don't know how to explain this in a way that's almost like doing it myself without actually just doing it. See, I want to add this angle and this angle and this angle. I want the angles of the triangle, right? Yeah, actually, it doesn't give us any more extra info than just adding the angles of ADB. Yeah, I mean, in any case, you get 180 minus the red dot, yeah,
Yeah.
plus 2 black dots, yeah?
Black. Then 180.
So that adds up to 180, right?
180.
Yeah, because if you add up the angles in a triangle, you get 180, okay?
Oh.
Okay, so that means 2 times the, well, actually, we already know this. 2 times the black dot equals the red dot, yeah? We already know this from there, see? Okay. I guess there's one kind of principle in math. It's like if I'm saying something for the red dots, I should probably say it also for the black dots, right? So, what did I say for the red dots? Oh, this is quite miserable, guys. This is just me talking.
And even more concentrate loss because of Michelle.
Yeah, Michelle, can you go somewhere else?
And now I don't even understand the question.
No, that's your fault, okay? That's not her fault. Michelle, get out of here, please. Okay, so the black dots are also acute, right? But they're actually even stronger than acute. They're actually less than 45, right? Because the red dots are acute, and 2 times the black dots equals 1 red dot. Hmm. Yeah, so let's just think of another way to draw this diagram. We could draw it like this, maybe. So we could draw the isosceles triangle first, like this.
Yeah.
So that's isosceles, yeah. And then we can extend this line until it's the same length as this line. and then join it up, right?
Yeah.
So if you draw it like that, so I think this problem has two directions, right? The first direction is like what angles are not possible, yeah? And the other direction is like what angles are possible. So, yeah. Also, it also says that the red dot has to be an even number, right? Before, so the red dot has to be an even number means that, um, actually it can't even be like 90. It can't be 91, right? It has to be 92 or 94. Yeah. So actually the angle has to be even as well, right? Okay. So that actually takes down a lot of possibilities. Okay, but if I can draw it like this, so no matter if I can draw the isosceles triangle first, and no matter where I draw it, I can kind of extend it into a valid diagram, right? Um, then that could be a way to prove that it could be certain angles. So, for example, um, so at the moment, the smallest angle it could be is 92, right? At the moment, the question is, can I actually get it to be 92, right? So I draw a picture where this is 92, yeah. Okay, so that means the red dot now has to be 88, you know. And if it's 88, this other angle here has to be, well, it's basically 4, right? And if this angle is 4, this is 44, this is 44, yeah? So the point is I can always start by drawing this triangle, okay? Yeah. And then I extend this angle, this line here, until the sides are equal, right? And if the sides are equal, and I join the base up, this angle will have to be 44, you know? So as long as it's possible for me to join the base up, then this triangle is also possible, you know? So that means, um, 92 is indeed the smallest angle, you know? It can be. Alright, so what's the biggest angle it could be? Well, at the moment, we don't have any better idea, so let's just try the biggest angle that fits what we have so far, right? So the biggest angle that we have so far is basically 178 degrees, right? Because it has to minus an even integer. So let's try if we can do 100 and that'd be pretty crazy though. So somehow we got 100 and there's 178 degrees, yeah? So here's only 2 degrees. And we're making an isosceles triangle. Where this is 2 degrees and then therefore this is 176 degrees, right? Okay. And then all we have to do is keep making that longer until these two sides are equal, right? And once those two sides are equal, we just have to join them back up, right? And if you join them back up, that means these are all 1 degree, right? Which is kind of crazy, yeah? So it's basically if these two diagrams here satisfy the conditions of the problem, then the biggest and smallest would have to be 178 and 92, right? So does it satisfy the question? What does the question say? The isosceles with integer number of degrees, right? Okay, so they clearly all have integer numbers of degrees. Yeah. Yeah. So then you, like if you didn't notice it, you might notice it when you try 179, right? Because you try 179, you get half and half, and it doesn't work, right? So yeah, actually, if you kind of were quick to sort of grab a hold of what the question is talking about, you could just try drawing the picture straight away, right? You draw the one with 90. Like if you knew it had to be obtuse, you draw it with like 90 and see it doesn't work, right? 91 doesn't work, 92 does work, right? And then you go 180 doesn't work, 189 doesn't work, 188, 170, sorry, 180, 179, 1 doesn't work, then 178 does work, right? Okay. Okay, and then what is the difference between 178? 178 and 92. Yeah, I understand you've been here since 4, so some of you are quite dead, so this might be a good place to finish. So what's the difference between 178 and 92? How about this? Come on, year 3 people, tell me what 178 minus 92 is.
178 minus 92.
Yeah. Yeah. 86. So yeah, 86. So let's do a summary of this, and then you guys, the year 3 kids, can go about their day. Okay, so